Hey, today we're going to be solving equations with fractions. That is, there'll be algebraic equations that include fractions. Before we begin, though, let's remind ourselves of something that is always true when it comes to solving equations. That is, to solve any equation, no matter how complicated, includes or involves undoing what is happening to the variable. We'll be practicing that, starting off with this problem right here. So I have m plus 4 and 5/6 equals 5 1/2. Now let's not be thrown off by the fact that it has fractions, and let's look at something a little more simple for a moment. And remember, the process is going to be the same. So if I had a problem like this, m plus 27 equals 59, I have, in order to isolate the variable, get it by itself, I have to undo what's happening to it. What's happening to it? I'm adding 27. So what undoes adding 27? Subtracting 27. But do I do it there alone? No, because one of my other rules I always have to remember is that whenever I do anything to one side of an equal sign, I have to do the same to the other side, whether I'm adding 2 to both sides. If I subtract 2 from one side, I'm going to subtract 2 from another side. If I multiply one side by 2, I'm going to multiply the other side by 2. The same thing for division. I always do to both sides of the equation what does I do to one. So if I subtracted 27 from this side, I'll subtract 27 from this side. The beautiful thing about this is this cancels those terms out, and I'm left with m equals, in this case, 32. The same process of undoing what's going on, I'm going to apply here. So what's happening to the variable? Well, I'm adding 4 and 5/6. What undoes adding 4 and 5/6? Subtracting 4 and 5/6. Since I subtracted 4 and 5/6 from this side, I'll have to do the same thing from this side. On the left side, these will cancel out, and the only thing I have left is the m will come down. And now I have this to deal with. 5 1/2 minus 4 and 5/6. Well, I notice that my denominators are different, so I'm going to have to get these to match. Well, it looks like I can make 6 a common denominator by multiplying both sides, top and bottom of this number, by 3. When I do that, I'm going to have 5 and 3/6 minus 4 and 5/6, which is great because the denominators are the same, but I can't take 5/6 away from 3/6, so I'm going to have to borrow and regroup. So the 5 is going to become 5 is the same thing as 4 plus 1. The 4 I will keep, and I will think of the 1 as 6/6. So 6/6 plus 3/6 is 9/6. So 5 and 3/6 is the same thing as 4 and 9/6. I'm going to subtract 4 and 5/6. Now my denominators are the same, and I can take 5 away from 9. So 4 minus 4 is 0. 9/6 minus 5/6 is 4/6. And can I reduce this? Yes, I can. I can divide top and bottom by 2. So my final answer here is 2/3. That is, m equals 2/3. Let's go ahead and check this. So is 2/3 plus 4 and 5/6, is it equal to 5 1/2? So this is a check. Well, again, I'm going to have to change this fraction here so it has a common denominator. I'll change this fraction here so that its common denominator is 6. So I'll multiply top and bottom by 2, so it gives me 4/6 plus 4 and 5/6 equals 5 1/2. So 4/6 plus 4 and 5/6 gives me 4 and 9/6. Does that equal 5 1/2? That's the question I'm asking. Well, 9/6 is the same thing as, I can write that as 6/6 plus 3/6, right? 6 plus 3 is 9. Does that equal 5.5? Excuse me, my writing's getting a little sloppy there. 6/6 is the same as 1. 4 plus 1 is 5. 5 and 3, 6. And we can see 5 and 3, 6 is the same thing as 5.5. So because that checks, I know that m equals 2/3 is my correct solution. Oh, happy day. We'll do another example here in the next video.